Welcome, everyone. Let me just describe how this is going to work in terms of the 2 semesters. We'll be learning how to use the program for all its sort of construction document functions. What it's basically made to do is from the 3D model that you'll build, it creates the plans. You don't have to draft them. Plans, sections, elevations, 3D views. And that's really entirely in monochrome, black and white stuff we'll be working. Next semester, we'll introduce color, images, lighting, materials, rendering, and animations. That's sort of the balance here. And as I said, 3D printing somewhere in there too. That'll maybe tie in more directly with Molly's course than with mine in terms of assignments. Revit's a big program, and to think that you're going to learn it from my handouts and the next semester and a half of school is like thinking that your driver ed instructor is going to teach you how to race Formula One cars and plan a trip to Vancouver and back. You know, I'm still learning Revit, and I've been using it since 2007 or sometime. I brought in some of the books I've been using since then, which I'm donating to the program. They come out every year with new release of the program, which really has just like minor upgrades each year, but that gives them excuse to print a whole new book. So here these are. I thought you'd like Instant Revit, Revit No Experience Required. Most of these work by developing a project from start to end, which doesn't tie in well with this course, but it's a very good self-study method. And a lot of them come with links to sample files, starter files on the internet. You can download them and use them. Give them a shot. They're very useful. I noticed that the AutoCAD for Dummies book doesn't seem to have been getting a whole lot of use. I would really like it if these did get some use, because I can't teach you everything. And frankly, as you embark upon a profession, I don't think you can expect anybody to teach you everything about anything. Everything changes all the time. I mean, you know, there's new releases. Most software gets updated at least once a year, and the intermittent ones through the year. So just keep your eye open. While we're at it, in terms of updates, when you install Revit, or probably Autodesk or AutoCAD if it was on the PC, also this Autodesk desktop app was installed on your desktop. And that's the basic place for checking for updates. Okay, I haven't done this on this computer yet, so we'll see what I have to go through to get. Oh, it knows. Okay. So this is telling me that this program itself needs to be updated. But basically, you can go through here and for either AutoCAD or Revit, pick that, and it will list the downloads that are available to you. And I would say none of them are really crucial, except any that says, say, like Revit 2023 hot fix or something. That means that that's really addressing a problem with stability or some other issue. We can ignore all the ones about lighting upgrades and that kind of stuff. If you have a question, ask me, but that's where that happens. Can I cancel this? Learning resources. Revit has its own tutorials. This is what's new in Revit 2023 compared to the previous version. Then there are videos and descriptions of how things work, how the tools work. These are either text or video links to understanding how the program works. And I use Google a lot. You know, Google takes me to YouTube videos. I just type in Revit brick walls, and up come 300 tutorials people have put together about how to do brick walls in Revit. So it's very, very handy. Books, and there are more of them. If these don't satisfy you, there's an author named Paul Aubin, A-U-B-I-N, the ultimate Revit guru, and his books are all excellent.
He also has a great series of Revit tutorials on LinkedIn.
He's the kind of guy who has modeled Corinthian capitals and saxophones with Revit. So he really knows what he's doing. What I like to do is just for me on the screen to give you a quick overview of how Revit works and what it can do. It's a designer's tool. You know, as you may have experienced, as I know you've experienced, AutoCAD is a draftsperson's tool, a draft person who's also a computer nerd. Revit was written by a bunch of architects who hired some software engineers who said, this is not the way designers work. We don't think flat, we think in 3 dimensions. We don't think in terms of plot style tables. We just think in terms of, do I want my furniture dark or light? They didn't want to have to deal with having to pick their text size for every different scale of drawing they were doing. And Revit, as a result, it was so successful that Autodesk, the maker of AutoCAD, bought it and made it their own product and continued to refine it. So just watch for this one. This is called the launch screen. It's what comes up when you first start. I don't think Revit's been run on this computer yet. So what we're left seeing, sort of the sample files. As you work, these guys will slide to the right, and the more recent files successively will come appearing here. So you can just sort of get it. Models, as you can see, are full buildings as a rule. And families are the Revit equivalent of AutoCAD blocks. A piece of furniture, you see a truss, a lighting fixture, the things that go in a building. What you'll come to appreciate, and certainly I do in Revit, is that it's thought through from the point of view of people who design, inhabit, and maintain buildings. It's made for building buildings. You don't do chemical models with it. You don't do roadways. It's made for doing buildings well. Let me just look at this one first. Okay, the main idea here, and this is a fully developed project. We create a 3D model using its tools, and the tools aren't line, arc, circle. The tools are wall, window, railing, floor. And then as soon as we created something, Revit is simultaneously generating the plans that we need to see that. So this is that same model. Let's close this. Oops, sorry. So this is the floor plan, and some things have been added. Obviously, the color and stuff has been added to this. If we zoom in on this model and pick the magic fireplace, it's selected here, it's selected here, and if over in this view I move it down a couple of feet, it moves down a couple of feet in this view. It's like multiple TV cameras aimed at the same three-dimensional object, some of which see it in plan, some of which look up and see a reflected ceiling plan. Some are perspective, some are elevations, but it's all one simultaneously updated model, or model and all the views are simultaneously updated. And I think the difference would be, compared to AutoCAD, Revit understands building components and understands that when two walls are within a certain distance of each other, this wall touches this wall and becomes joined with it, in fact. With AutoCAD, if two lines got close, they're just close. You know, there's no intelligence there. So my tools are building elements. I place a window. Revit knows to place a window in the wall, and it should be, and there it is, right there. It's inserted into the plan view. It's a nice way to design, and especially to design with multiple views at the same time, so you can do something in plan and understand the implications either in three-dimensional axonometric drawing or in a perspective view. There are no layers in Revit. In AutoCAD, I like to use the layer called A-wall for my walls. Somebody else might like A-wall-, then there's some masonry or something or other else. Just other people just might say wall, other people might say W. There's no consistency through AutoCAD unless it's enforced by you or enforced by your office. People put Revit together decided that's totally bogus. There's no way that different firms or even different people in the same firm can share information. So they literally sent people all over the world to find out what goes into buildings. What are the categories of things that go into buildings? And there's some obvious things like walls and doors and windows, furniture, casework, toilet fixtures, lighting fixtures, conduit, electronic devices. And they broke that down into, like, I don't know, maybe 50 different categories. And so now when you go to create a piece of furniture, let's say, you go into that particular menu and it says, okay, what kind of a thing is this? And it gives you a list of those 50 things. And those are the only things it can be. You can't make something, well, you can make a generic object that just sort of like a teapot or books on a shelf or something. But for any true building elements, they've really got it covered already. And the result of that is a firm in China can send me a Revit file and all their furniture is in the furniture category, all their floors are in the floor category. regardless of which measuring system, metric or feet and inches, regardless of which language it was created in, all the Revit models compatible with each other. There's no issues of their names, their colors like that. And as we'll see, these plans have been colored to show some sort of departmental uses, like bedrooms are one color and living space is another. But these different categories don't need to have colors in Revit, because if it's a chair, and you can tell it's a chair. You don't need it to be orange to tell that it's a chair or not. I think you'll like it a lot. Okay, so we had the launch screen. We'll start our own little drawing that we can all work in at the same time. Here, I'm going to start with creating a new model. We're just going to create a little house. As with AutoCAD, we have a choice of templates, and I would like to use, and we'll fix this so this doesn't pop up first, but I really like to use the Imperial architectural template. So feet and inches and architectural, and that comes with a couple of pieces of furniture, some trees. The construction one comes with like a dumpster and a porta potty or something or other, but Imperial architecture and a new project. And here we are in our workspace. The parts of the screen will be fairly familiar to you. This is called the quick action toolbar. And you can put any tool that you want up there if it's something you just use over and over again. So we've got file open, file save, print, export to PDF, that kind of stuff up here. Then we've got the regular ribbon menu, next thing down. And some of these we won't need and we can turn them off. Mostly we're not dealing with structure, we're not dealing with steel, we're not dealing with precast. So we can turn those off. It's a ribbon that works much like any other Autodesk ribbon. And each of these then has a couple of different ways to do something, depending on what you know about it to start with. A wall will have different kinds of walls. Railing will have different ways to create a railing. So that's the main ribbon toolbar. It's always up there all the time. Then we have, as in AutoCAD, a properties palette, where if nothing in the drawing is selected, it'll tell you sort of about this whole view. And then we also have a project browser, and this is different from AutoCAD, but this takes you to the different views already set up in that template. Floor plans, ceiling plans, and then the north, south, east elevations, which are already indicated by their north, east, south, and west elevation markers. Each of these actually creates an elevation of whatever we draw, as well as being able to take us to see that elevation. As in AutoCAD, these palettes are dockable, which means that they can be, you can use them undocked, just floating. But then stuff is like underneath them and it's sort of a pain to work with. You're always moving them around to see. So if we grab it here and push it over to the side till it sort of lights up there, then it'll dock to the side and stay put. And then the next one, I like to have project browser on top and properties underneath it or next to it. If we slide it, just slide it over, it'll show in next to them. You can arrange these either way you want them. Project browser. Sort of play with those. Or if this starts taking up just too much room on your screen, you can drag the properties browser, let's say properties palette down here until it'll stick in there underneath the project browser. Or you can stick it all the way over here and have it dock on that side. Yeah. Oh, okay. Sorry. Project browser. Over here in view, the last choice is user interface. And then you can click to turn on project browser. I'm going to seriously recommend that anybody who's working with a laptop consider buying a monitor from Best Buy or somewhere. Having this space to see what you're working on is really a boon. It makes the project more real, to tell you the truth. So we got a launch screen, we got a ribbon menu, we got a project browser, we got a properties palette.
As we saw before, the work area can hold one or more views.
2D navigation, just holding down your mouse wheel you can drag and pan and then zoom with the mouse wheel, zooming in and out. Let's draw a little building and then start to understand what's going on. Let's just pick architecture wall. You just click and click and click. Revit is smarter about understanding when you want to be working orthogonally and when you want to be working on an angle. But if I just start here, you can see it gives me a little light blue line to indicate, okay, you're on your orthogonal measurement. And I'm going to make a house, just some sort of randomly shaped L-shaped house like that. And as you come back across here, it'll line back up with that, indicating those connections. What we've just done there, we're always working in 3D, even though we're seeing it in plan. So if we go to View, 3D View, which is used so often that's also been stuck up here on this quick action toolbar. You can hit either one of those, it's the same thing. We see in 3 dimensions what we were just looking at. And then over here, we have this same view cube that we had in AutoCAD to sort of be able to see and rotate stuff in 3-dimensional space. We're clicking on different corners. We'll take you around like that. And if you drag and highlight over the moat, I guess you call it, click on that and drag, and then you can rotate around this way. And that's just technology. Either they borrowed it from AutoCAD or AutoCAD borrowed it from them, I forget. And then clicking on any of these faces takes you into that elevation view. Or the top view, either one. And if you get all turned around and upside down, you can always just click this little house and it brings you back to this same spot. Sort of home base, looking down at things. The last thing to mention is, as in AutoCAD, if you hold down the Shift key while you use your mouse wheel, you can orbit freely around it, high or low, or just whatever view you happen to want. So over here, I'm going to call your attention to the main sort of conceptual difference between how Revit organizes space and AutoCAD does. Is AutoCAD has there's that 000 point, which is down, on the floor somewhere, and everything is in relationship to that. But it has no real way, unless you do them side by side, to do first floor and second floor.
Like we've done for Schneider Hall for Molly's class.
The way it gets around it is you do the first, in AutoCAD, the basement is in one CAD file, first floor is in another CAD file, and you reference this one into this one, then you have 2 of them stacked in another drawing. And it's a total pain in the butt because you have to keep switching back and forth if you want to change stuff, and they're not linked in any way. So if you move a column grid in one, they don't move in another. So Revit really is completely different, and the major concept it uses to organize space is just the idea of a level, which translates most directly into basement, first floor, second floor, and on up as far as you want. And a level is an infinite flat plane. It doesn't curve with the earth or space-time or anything. It's just flat. Most buildings work out small enough not to worry about the curvature of the earth. Infinite horizontal planes, and we can rename them to, instead of level 1, level 2, we can call that first floor, second floor, whatever we want. We optionally I'll get back to my floor plan view. We can optionally insert column grids which can start to organize space vertically. So layers are taking it this way, column grids are taking it this way. We don't use them much in interior design. We inherit them from architects and engineers. And they're really used to define the main structural organizing grid of a whole building. You wouldn't use a grid just to lay out the stuff in this room, for instance. And then go horizontally as well. So we get a 3-dimensional matrix where things can be located. There also, we'll get into this later, the idea of a reference plane, which can be vertical, horizontal, or slanted. I did this in set design, a slanted stage. It's called a raked stage. It slopes down towards the audience. and you want to be able to put furniture on that.
It's not sitting on a level, it's sitting on the rake.
So that's a case where you'd use a reference plane that can be at any orientation. And then the things that go into this organized space are elements, we'll say, of a couple of different kinds. The main ones are floors, walls, ceilings, and roofs. And those are hosted by a level, and hosted means move with and are part of. So if let's put a floor in here. Let's just go to floor. And I can say, okay, there's my floor going to be. And then we can see that that got added to the building. And actually the floors don't go out like that. But until the walls come down past it, which they don't, because right now the walls start at level 1 and the floor goes down from level 1. But you can see that what's happening there is that level, our level 1 here, is telling the walls where to go, where to start going up, and the floors to start going down. And if I move that level down, then the floor will go down. They will all go down with it. And let me just show you how that works. I'm just going to take that and move it 5 feet in that direction. And they just all go down with it. They are attached to, hosted by that level. These in turn, the major elements, the floors, walls, ceilings, and roofs that are hosted by a level, they in turn host their own objects, their own sub-objects. For instance, furniture. If I go back into my plan view, well, let's go over to here actually. And it's worth noting we can pretty much any operation we want to do, we can do in any view. I can insert furniture in a 3D view. I can insert furniture in a plan view. Component is where we add all this stuff. Place a component. The default one is just a desk. And if I put it here, now you can see that that's down there on that floor plane. I could have done the same thing over here. And it would end up being on that same level. Similarly, the way that the walls and the floors move with the level, component objects can move with the thing that they're hosted by. And let's take a window, for instance. Put a window here in this wall. And it's not just like the window is hovering in space, it happens to be where the wall is. If I move the wall, the window goes with it. Same with doors. Same with wall cabinets, kitchen wall cabinets, because they're attached to a wall. And if the wall moves, they have to move. Light fixtures and fans and that kind of stuff get stuck to a ceiling. Skylights get hosted by a roof. Let's do a roof just while we're at it. I'll go to my level 2. That's the tallest one I have, and create a roof. A couple different ways to make that. I'm just going to say roof by footprint, which is to say corner to corner to corner, tracing it around in plan. And this time I'll just trace it. And whenever you're creating a 3-dimensional object like this, you get the it's outlined in magenta, so you know this is what I'm working on. Now I'll say okay, and I'll say don't attach for right now. Get back to 3D, and my roof is a little too far down, so I'll get into a elevation view. And pick it up. When I say that Revit understands buildings, It means it understands how they're put together and how the parts interact, and it knows that walls very often come up to a roof. So I'm going to pick this wall right here, say attach it to the roof, and then it'll extend it up there, and go around and do that for all of them. When you're selecting things with AutoCAD, you can just sort of keep picking things and they'll all be selected. With Revit, you have to be explicitly saying, I picked that, and now use Control Pick to select any others you want to select. Then when I've selected them all, I can say attach to this, and up they go. I know I'm throwing a lot at you right now, so don't despair if you get a little behind. So that's stuff on my first floor. Let me think about a second floor. And right now I don't have a second floor in there. I just have a first floor and all the way up to the roof. But if I go into my level 2 view, where you see I'm seeing faintly down to those desks on the first floor, I can go to floor, architectural. What I have to do, I'll click and click and click and click and click and click. I'll say okay. Now what it's asking, because Revit understands about how buildings are put together, now that I'm putting a floor in here, it's saying, the way these are built is this guy gets notched into that structurally. Do you want that, how we're drawing this, how we're modeling this to reflect that actual condition? And as a rule, I say yes. So now I got my second floor in there. And if we go to a 3D view, you can see that coming through there. I actually didn't want to see that. Well, fix that wall type. If I go back to level 1 and set up a camera to be able to see this first floor, so that's with view. It's a subset of 3D views, which is a perspective view from a particular camera point. I'm going to put it here and look that way. WT tiles the screen, ZA does a zoom all, so I see everything that's there. And again, if I move a desk in one view, I gotta select it, it moves in the other views. So there's really no one place like model space in AutoCAD where you come back to do everything and then see what it looks like in a view on a sheet. We're sort of working through these different views, whichever one is appropriate to the task at hand. When it comes to putting them on a sheet, this view, we can see it has a border. This one does not yet have a border, an edge to it. So I'm going to click in here, and we have each of these views has a couple of different, let me just fix this a little bit. Each view, when I click out here in the view, I get the properties of the view. Each view has what's called a crop window around it, which is basically the size that we're going to end up putting it on a sheet. So first of all, I want to see where that region is. And that's a lot bigger than we need to have on a title block. So I'm going to click it and just drag it into the framework of this. Perspective views have no scale because things that are closer to you appear larger than things that are farther away. But floor plan, we need to be able to specify what scale that is when it goes onto a sheet. And we can do that down here. I can change that to 1/4 inch equals a foot. Nothing changes here. You notice that the text in these bubbles did shrink automatically down. So when it gets larger on the screen, it'll be the same size. But I'm going to take that back to 1/8 just because I think that's kind of a big building. So for putting these on a sheet is really pretty clean, but let's do a couple things first. Let me put some more windows and doors in here. Floor plan is a horizontal section cut through a building. And by default, that's taken at 4 feet off the floor. At this point, my window is 7 feet off the floor. So if I change this back to my sill at, say, 3 feet, then the window will show up. Was it just one window I had in that wall? Oh, there, and there's that one. So I can pick it here and change it to 3 feet. And I'm going to put some doors and windows around in this room, just so we have something to show in our elevations. Architecture, door. And you notice that it's not only placing the door, but cutting the wall and all that kind of good stuff. What we see right here, that line is the edge of the floor that's below it, sticking out to there. Okay, let's create some elevation. Let's put a few more windows in, just so I know what I'm looking at. Okay, elevations, view, elevation. The first little marker aims at the wall you want to look at. So I'll say that looks good to me. So just placing that there creates this elevation called 1A, which is this right here. So there, there's the door and the window and the edge and the desk, and the door and the window and the edge and the desk created automatically. Oh, and I should show you, when you select it, when you place that elevation symbol, what it's looking at, it goes over it till it hits a wall
To either side.
and then looks a certain depth. Let me put a window in, some windows in here. And because the depth of this view right now doesn't go as far as that wall, we go to that elevation and we don't see them. But if we go back to level 1 and just drag that out and go to elevation 1, then we do see them. So we have a lot of control that way. If there's something interesting going on, this could go as far as you want. But by default, these come in a fairly, 20 feet or something or other, so that if it was infinity and you're working on a model of a city or something, you'd see all the way over to Indiana with all the buildings in the way, and we don't want to do that. Adding elevations is simple. We simply click this, and then we see it potentially can give us 4. And if we click that one to make it active, then that appears. And then it shows us what we're going to see here. But you notice that it's only showing from this wall to this wall, not all the way down to there, so we can see that full wall. So I think what I'll do, I'll just drag this up. I can drag it to where I want that to happen, and then tell it how deep to go. Let's say I want to see a section through the walls. I can drag it out a little bit farther. And double clicking on that takes me to that drawn elevation. So a section through the window, desks, all that. And this goes up to I think it goes up to the level above, as opposed to say a ceiling above. I'll drag it up and see. Oh, it took me to the bottom of the floor above. So it gives you wall to wall and floor to ceiling, actually to bottom floor, which is a little weird. But if you want to stretch it, you can. So let me go back and create those other
2 elevations.
Turn them off. And then for putting these on a title block, which Revit calls sheets, I'm right-clicking on sheets, going to new sheet. We'll start with this 30 by 42. That's a big sheet of paper, but it's what's here right now. I want to use it. There it is. And then to place these views, I'll pick my level 1 view, drag it in place with my elevation markers, and I'll drag my elevations, and they line themselves up. You can see there with the blue line. So the floors and all are lined up. It really beats the heck out of drafting. I have to say, we get to think about, do I really want a window lined up with each of those desks, or would I like the windows between the desks? We make design decisions, not drafting decisions. And it can be any sort of a view. We can bring our 3D view in. You see, this is one that has not been cropped yet. But right here on this page where it's becoming obvious, I can, with this active, I can say, let me see that crop region. Okay, there it is. Oop. I'll bring it in here. I want the view cropped, but I don't want to see the box around it. So I'll say crop it, yes. Don't let me see the box. Same with that guy. And these all already have their drawing numbers on them. So if we go back to our floor plan view, you can see it already knows that those 4 views are numbers 2, 3, 4, and 5 on this sheet A101. And if I change this sheet to A105, that'll change to A105. Just a lot of stuff that you have to do manually and painstakingly in AutoCAD, referencing things back and forth, are essentially completely handled. I'm glad you had to do it once, and I know you are too, but life is too short to spend your time doing that stuff, especially when software will just do it. There's one other really significant difference between Revit and AutoCAD, which in AutoCAD, there's always the question of, do I dimension in my model and then worry about the size of the text once I get where I'm going? How does that all work? And Revit really takes care of that completely well. And first of all, since there's no model space, you don't dimension in model space. Making dimensions here in a view, and let me just do that. DI for dimension. All of the annotation, dimensions, text, labels, all that sort of flat informational stuff only shows up in the view where you placed it. So if I go back to my sheet, you'll see that the dimension I put there in the floor plan is showing up here. It's hard to explain how easy this is. You just put dimensions where you want them and annotation where you want them, and they don't show up in any other views. That's it. And for things like room names that do have to show up in multiple views, we'll get into that, but it's very easy for Revit to duplicate those and put them in whichever views you need them in. And one reason for doing it that way is sometimes on a small room, let's say a bathroom, you've just been able to fit the word bathroom and the room number in on the floor plan. But then when you get to the lighting plan, and there's only like one place you can go, you get to the lighting plan and there's 2 lights in the ceiling and those letters are covering that up, and you've got to have to move the room name and it moves it in the floor plan, and now it's covering up the toilet. In Revit, you have 2 different labels and 2 different drawings, and you just put each one where it needs to be. It's very clean. Give you a little illustration of that. I'm going to put another wall down. I'm going to put a wall right across here. And I'm not paying attention to any attention to what kind of walls these are. But they do have materials and, oops. Well, it's actually a little illustration of how Revit objects link to each other, but I'll digress. You know, they cleaned it up right there where those two met. It's the same material, so it just goes right across. If I want to put in room labels, and pretty much in Revit, whenever you are giving something a label, if you're applying a label to an actual thing, you're not just putting a piece of text on a page, you're actually giving it a label. For instance, if I want to tag all my doors, this is an actual door that I've tagged. It's called door number 1, and we can refer to that. At this point, I can't tag a room because I don't have a room yet, but there's a tool called a room tool, architectural room, and we'll be doing this all semester, so don't worry about it. And now it sort of looks till it finds walls on all sides, or as many sides as it has, and puts a room in there, and puts a room in here as well with a label. So I'll just keep calling them room 1 and 2. If I create if I duplicate this plan, let's say I want to have one at a different scale or something rather, duplicate view, level 1 copy. I don't have the room numbers in there, and so the annotation, the room numbers, and the dimensions went away there in that view, because those are two different views of that. Maybe I'm going to use this for the carpenters and this one for the plumbers or something or other like that. But they can have completely different sets of dimensions, completely different sets of, maybe this is the furniture placement plan, where I do a, so two different views of the same plan, but the furniture plan has furniture dimensions and the framing plan has framing dimensions. Let's look at a couple of the drafting tools for a minute, because everything we do with lines, we can then start doing with walls, which are essentially, as Revit thinks of them, lines that have some width and volume associated with them. If I go into architecture and decide to draw model lines, it stopped showing up because this view had its crop region, its rectangular crop region turned on. I'll turn that off in this view. If I draw another line from that endpoint and click to that line, then an important concept in Revit is the idea of constraints, which is when you tell two things to join at a corner, for instance, they stay joined at the corner, regardless of what happens to one of them. So if I have these two drawn corner to corner and then move that, this one gets shorter. I can move this around, the other one doesn't change. But if I angle it, but if I move it, this one gets longer. And walls work the same way. Even if they're drawn separately, whenever you draw it and snap to an endpoint like that, it's more than just snapping. It's like gluing them or welding them or something rather. So that as one moves, the other moves. And that's just the way that design works. If you have to have it not move, you might come back, drag this back a little bit, move that, and then move it back up. But by and large, when one's moving, the other one wants to follow along with it. LI is the shortcut for line. If you have a line or two that want to be extended to another line, all the editing processes happen over here on the Modify tab, which is always the last one over on the right. Where we want to be, these are the main geometric ones. This is like fillet with radius 0 in AutoCAD. Wherever two things are in space, it brings them to the point where they meet. Whether they cross or don't yet cross, it brings them to their point of intersection. This one will extend a single element to another one. So I want to this, I want to extend that. If you want to keep doing that for a bunch of them, you can pick the one where you have multiple things being extended to the first. And down at the bottom, it's telling select a reference as the trim or extend boundary. You pick that, and then you pick the ones that you want to extend to it. And then, because they have been drawn to it, there's a link between them. Go touch this guy, then they are constrained to each other. And as you move the one, the others move. And walls work the same way. extend, boundary, wall. It's the same tool as the one that does the trimming. That's my trim. Then I pick the edges that I want to keep, and it gets rid of the rest. Typically, the way that a design process works is you figure out where your walls are first. Maybe that's a given, or you make those decisions first, and then you start to populate that with furniture and toilet fixtures and all that kind of stuff. And very briefly, those are all over in, well, doors and windows have their own, because the routines that insert them have to find an acceptable wall to put them in. And we saw how those worked. You just pick them and go. And there's many sizes and styles, and we'll get into that. But for the furniture and casework and stuff, these are all called components. And we can create our own using some of the same modeling techniques that we barely scratched in AutoCAD, or we can place them, which is say take one that's already made and put it somewhere. And there are a couple that come with this template. We click on desk. We can say we got a desk of a couple of different sizes, some parking spaces, some trees, a picture frame, pretty random stuff as far as I'm concerned. What we really want to do is go load a family, which is to say go out and get one of these blocks from the really huge library of blocks that Autodesk provides with Revit. And remember when I talked about there not being any layers, what Revit has instead of layers is basically these categories of things inside buildings. So there's annotations, a bunch of different doors, commercial doors, residential, different kinds of hardware. But let's go to furniture. And then furniture is broken down into, here's some sort of random generic things, and then there, let's just say seating, and it comes with ugly corbu chair, and any of these that you might happen to use. And we can make our own. I'll just say the sofa, and then open. And then like, as in AutoCAD, the sofa is now part of this drawing file. We could send it to somebody in China and they'd have this exact same sofa here. We don't have to like send lots of little pieces along with it. And it gives you a little preview. And then we can put it in place. And if you use the tab key, spacebar, it'll rotate it 90 degrees to maybe orient with some other piece of, whatever line it happens to be near. And you can keep on placing that. That exact same method applies to every kind of thing. Basically, anything that comes on a truck to the building. It's not built into the building like a door or window, but you can go to Home Depot and buy it and put it in place. So place a component lets you choose from the things that are in the drawing right now. If you want to get more stuff, you go over to Load Family, and it'll take you to the same folder where you were before. I'll move up into, let's say, plumbing fixtures. A lot of these are divided into categories that the engineers are responsible for placing and the ones that the architects are responsible for placing. And there's some overlap there, but generally we'll be using the architectural ones. And equipment would be like water heaters, who cares? We want to go to fixtures, bathtubs, drains, showers, sinks, like that. Just go to bathtubs. And I'm going to pick a freestanding 3D tub rectangular 3D, that one, and then open. And you might think you can put this in the middle of a room. That would be the freestanding one. These guys need a wall. So there that is on that wall. And if you move the wall, it moves along with it.
The tub is hosted by the wall, much the same way that a window is.
If you have something like this that you want to put on another wall, right now the idea of the hosting I want to work on. The bathtub is hosted by this wall, if I want to move it up to, so I can move it actually along anywhere along here, even outside the room, it's sort of attached to that plane. If I want to move this guy up to this wall, I say pick, I select it and say pick new host, at which point I can bring it over to here. And it's like a window, you can't just put it randomly in space, and with this you can't either. I think at this point, I like to do a little bit of 3D and rendering exploration, see where we get. I've got a room full of desks and a bathtub and a sofa. The sofa, incidentally, is just hosted by the level, so I can move it all around here and it just stays on the same flat plane. If I wanted to move it to the second floor, I could copy it up there. Modify, rotate. In terms of how this works with rendering, which we're not really going to get into, but you might want to, people tend to want to explore it. I'm going to set up a, first of all, you can't render in 2 dimensions. Rendering is a matter of light coming in and bouncing off stuff. We always have to be in a 3-dimensional view. It could be axonometric or perspective. Let's just go right for perspective. We do this camera view again. View, 3D view, camera, and start here and look that way. So I got a ceiling, I've got a floor anyhow, I've got windows, I've got a bathtub. Anyway, so rendering is easy. We go to view, render, and we have a couple of decisions to make. A quality setting, I'm going to leave that at draft. We'll pick it up later. The lighting, we're inside, but we don't have any light fixtures yet, so I'll say inside with only sunlight coming through the windows. And we'll say render. See what happens. It won't be lovely. But it's there. We'll get there. We'll get there. Okay, that was it. That's quick. We need a ceiling. We need some light fixtures in the ceiling. We need a material on the floor. Let's start with those. So if I go to architecture ceiling, I can do automatic ceiling. I'm in a floor plan view right now, looking down. So it's not going to, this view won't show the ceiling, but I'm going to place it here anyway. And it says none of them are visible in the floor plan view. Plan views are taken from about 4 feet looking down. Ceiling views are taken from like above the doors looking up at whatever else is there. So if I go into my ceiling plan of level view, then we'll see that guy. And I mean, if this is a residence, you wouldn't have drop-in ceiling, but we'll do that anyhow. So let's put some light fixtures in. Component, place a component. We don't have any light fixtures, so I have to go to load family, scroll up to one of our categories, lighting, architectural. This should say exterior and interior, but that's what this means. Ceiling light, flat round ceiling light. Open. And I'll put a couple of these in. It's not hard. You notice that they're sort of lining themselves up with each other. Go back to my 3D view. We got a ceiling, we got light fixtures. Let's pick this floor. There we go. And change it from just a generic gray floor to wood joist with the wood finish on top. So we get our railing there and we'll say, okay. Okay, do that. Let go. And then render that again. So this is the view we want to render. View, render. Let's make it a little nicer. Let's take it up to medium. It's remembered our settings. Now we need to tell it interior view, but using sunlight or whatever's coming in the windows plus the artificial lights. I'll say render. And it'll take a little longer because it has to do more calculations with the as the cones of light overlap and intersect. And there's more of them, and we got more materials to deal with. But it's really easy. the pictures I showed you the renders I did with AutoCAD last week, I did those because this stuff was not available. But now I'm teaching you guys how to do it. It's time to retire, The fact is that the firms who used to call me to ask me to do this, they just hire somebody in who can do it. I mean, you'll see in the one ads, AutoCAD/Revit preferred, and this is one of the reasons why. Those walls really need some work. I don't know what they're made out of. Let's just pick that wall. Sorry, that wall is a basic, just generic wall. Let's do this. Let's select that one, right click, select all instances in the whole project. And we're going to change them from basic wall to, this is just like a Gypboard partition. It should be lighter. View, render. This is Kentucky. If you can have the refrigerator on the front porch, you can have the bathtub in the living room. Anyway, so that's sort of the big picture of how things are organized, how you work with them. We can save that view and stick it on a sheet. I mean, we save the rendering just the way it is. Let me just do that actually. And you notice how there's light that's flaring up onto the ceilings from these guys. It goes up there and then bounces down here. I mean, it's really pretty great. Once here, I can save this image to this project as a rendering. Call it first 3D view with materials. And then that shows up here under renderings. And that's just another view that you can stick on your sheet and print in color when the time comes. Revit and the color plotter is a really nice combination of things. I'm talked out. I'll give you a little heads up. I think what we'll do for the first assignment is Wednesday, we will import your 2D AutoCAD plan flat into Revit and then essentially trace on top of that. And I think it's important when it's a space that and you know what the windows look like and what the doors look like, then you can work towards them instead of just accepting the default stuff out of the box. Really have to explore the libraries for what's there.